Now let's look at what to do when we are adding or subtracting rational expressions that have unlike denominators. In other words, the denominators are not the same. So if the denominators are not the same, we can't immediately add the numerators or subtract the numerators. We need to build these fractions up to the point where they have the same common denominator. To do this, we generally want to use the least common denominator, which is just another way of saying the smallest common denominator that works for both. We're generally going to build to that least common denominator, make the fractions a little bit bigger. That's why we say build. And to do that, we're going to do a kind of a specific process to find that smallest value. The best way to kind of explain it is to go through an example while we explain. So the first step, no matter what the problem is, if you don't have the same denominator, is to rewrite the problem with factor denominators, because part of finding a least common denominator is going to be looking at the factors of those denominators. So here in my first example, I have x over x squared minus 5x plus 4 as my first fraction, and I have 2 over x squared minus 16 as my second fraction. So I'm going to keep the numerators exactly as is and just go ahead and factor out the denominators. So in my first trinomial denominator, I'm going to have x times x, and then I want to factor a positive 4 to negative 1 and negative 4 so that we get a negative 5 when I add up. My second denominator is a difference of squares, so I'll factor that with its square roots, x plus 4, and remember, switch the sign, x minus 4. So now I can see my denominators factored out. And how we create the LCD, and I'll put it right here, LCD is going to be equal to do this, we're going to take the entire first denominator, x minus 1 times x minus 4, and then we're going to multiply in whatever is in the second denominator that is missing from what I currently have. So currently I have an x minus 4 in this LCD, so I don't need another x minus 4. What I need is this x plus 4. So I'm going to add in, or technically multiply in, so add is in put 1 in, but technically I'm multiplying in x plus 4. Now when you look at this LCD, it has both the first denominator and the second denominator. So the first and the second is included. So both denominators technically are in the LCD. This LCD is what we're going to use as our common denominator. What we want to do is rewrite both fractions with that as the common denominator. So in fact, I'm just going to go ahead and automatically put my denominators in with that LCD. So writing each fraction with that LCD of x minus 1, x minus 4, and x plus 4. Next, what we want to do is think about how to adjust the numerators to compensate for this change. My first numerator had an x, and then what I've added into the denominator, or multiplied into the new denominator, is x plus 4. So I need to multiply the x by x plus 4 to balance it out. The idea here is that I'm going ahead and not changing the value of this fraction, because technically I'm multiplying it by 1, because I'm multiplying it by x plus 4 over x plus 4, which is just 1. So I haven't technically changed the value of it. So in building a common denominator, I'm going to rewrite the problem using the LCD and the denominators in both fractions, and I'm going to adjust the numerator accordingly by multiplying by the missing factor that that fraction didn't have. In my second fraction, I had a 2 in the numerator, and what I was missing to have the LCD was the x plus x minus 1. So this x minus 1 needs to be multiplied into the numerator as well. Because it's multiplied into the denominator, it needs to be multiplied into the numerator. So now, what I have in my first fraction is x times x plus 4, which is x squared plus 4x. And we do multiply out that numerator over the common denominator. And in the second fraction, multiplying the numerator out, we have 2x minus 2 over the common denominator. At this point, and I'm running out of room going down, normally if I had a full page, I'd keep running down the page, but now what I'm going to do is add the numerators. I'm using an arrow to show that I'm coming up here. When I add the numerators, I get x squared Plus 4x plus 2x is plus 6x, and then minus 2. And my denominator is x minus 1 times x minus 4 times x plus 4. So I now have a single fraction. The numerator is simplified. We generally don't multiply the denominator out. We leave it as is. To try to simplify the single fraction, we might try to factor the numerator. But when you look at it, it's not going to factor. So in this case, this would be our final result. We didn't cancel anything, so we don't have to list out any domain restrictions.